Hello everyone, today I will be talking about routing concepts. In this video, we will cover the contents, introduction to the routing concepts, the concepts of forwarding and routing and why they are actually important in routing. You will understand what forwarding table is, and you will see the traditional and the software-defined network approach of routing. And finally, at the end of the video, I will show you the internal construction of a router so that you can understand what's exactly inside a router. Networks allow people to communicate, collaborate, and interact in many ways. Networks are used to access web pages, talk using IP telephones, participate in video conferences, compete in interactive gaming, shop using the internet, complete online coursework, and so many more. Ethernet switches function at the data link layer, which is layer 2, and are used to forward Ethernet frames between devices within the same network. However, when the source IP and destination IP addresses are on different networks, the Ethernet frame must be sent to a router. A router connects one network to another network. That means the router is responsible for the delivery of packets across different networks, right? The destination of the IP packet might be a web server in another country or an email server on the LAN. The router uses its routing table to determine the best path to use to forward a packet. It is the responsibility of the routers to deliver those packets in a timely manner. The effectiveness of inter-network communications depends to a large degree on the ability of routers to forward packets in the most efficient way possible. Why is routing important in networks? The first thing is router connects one network to another network, determine the best route to the destination before forwarding traffic to the next router along the path. And the third one is it's responsible for routing traffic between networks. And routing table used to determine the most efficient path to reach the destination. But before coming to the details of a router, let's see the general concepts behind routing and routers in connection with the network layer, because routers are network layer devices and routing is a function in this layer. Here in this figure, we can see a simple network with two hosts, H1, here H1, and H2, and several routers on the path between H1 and H2. Let's suppose that H1, this host, is sending information to H2, the host on the other side of the network, and consider the role of the network layer in this hosts and in the intervening routers, because you can see that there are so many routers which connect different networks. The network layer in H1 takes segments from the transport layer in H1, as you can see here, encapsulates each segment into a datagram, and then sends the datagrams to its nearby router R1, as you can see here. As the receiving host, H2, the network layer receives the datagrams from the nearby router R2, this router, extracts the transport layer segments, and delivers the segments up to the transport layer at H2, or the second host here at this point. The primary data plane role of each router is to forward datagrams from its input links to its output links. The primary role of a network control plane is to coordinate these local per router forwarding actions so that datagrams are ultimately transferred end to end along paths of routers between source and destination hosts, as you can see from the figure clearly. Here the routers are shown with a truncated protocol stack, that is, with no upper layers above the network layer, as you can see from this stack, because obviously routers do not run application and transport layer protocols. Now let's see the two primary functions of a router, which are forwarding and routing, which are very important in networking and in the routing concepts. So the primary role of the network layer is to move packets from a sending host to a receiving host. To do so, two important network layer functions which are handled by a router can be identified. So the first one is forwarding. When a packet arrives at a router's input link, the router must move the packet to to the appropriate output link. That's actually the ultimate goal of routing. For example, a packet arriving from host H1 to router R1, here in this figure, must be forwarded to the next router on path to H2. So this should be a path that actually takes the packet from H1 to H2 all the way to H2, crossing all the routers. So routing is another concept, which is the network layer must determine the route or path taken by packets as they flow from a sender to a receiver. So the algorithms that calculate these paths are referred to as routing algorithms. Routing algorithm would determine, for example, the path along which packets flow from H1 to H2. The terms forwarding and routing are often used interchangeably by many people discussing the network layer. But forwarding refers to the router local action of transferring a packet from an input link interface to the appropriate output link interface and takes place at very short time scales, typically a few nanoseconds, and thus is typically implemented in hardware. However, routing refers to the network-wide process that determines the end-to-end paths the packets take from source to destination and takes place on much longer timescales, typically seconds, and as we will see, is often implemented in software. A key element in every network router is its forwarding table. A router forwards a packet by examining the value of one or more fields in the arriving packet's header, and then using these header values to index into its forwarding table. The value stored in the forwarding table entry for those values indicates the outgoing link interface at that router to which the packet is to be forwarded. For example, in the figure, a packet with header field value of 0110, as you can see here, arrives to a router. And then the router indexes into its forwarding table and determines that the output link interface for this packet is interface 2, as you can see. The router then internally forwards the packet to interface 2. Now let's see the traditional approach of routing, because there are actually two types of approaches for routing. So the first one is the traditional approach. So here are routers forwarding tables configured in the figure. So the question is, how are routers forwarding tables configured in the first place? This is a crucial issue, one that exposes the important interplay between forwarding in data plane and routing, which is always in control plane. As shown in the figure, the routing algorithm determines the contents of the router's forwarding table. In this example, routing algorithms runs in each router, and both forwarding and routing functions are contained within a router. The routing algorithm function in one router communicates with the routing algorithm function in other routers to compute the values for its forwarding table. How is this communication performed? Simply by exchanging routing messages containing routing information according to a routing protocol. The distinct and different purposes of the forwarding and routing functions can be further illustrated by considering the hypothetical, which is obviously unrealistic but technically feasible, case of a network in which all forwarding tables are configured directly by human network operators physically present at the routers. In this case, no routing protocols would be required because the forwarding tables are configured by human network operators. Of course, the human operators would need to interact with each other to ensure that the forwarding tables were configured in such a way that packets reached their intended destinations. It's also likely that human configuration would be more error-prone and much slower to respond to changes in the network topology than a routing protocol. We are thus fortunate that all networks have both a forwarding and routing function. Now here comes the software-defined network approach. The approach to implementing routing functionality shown in this figure, with each router having a routing component that communicates with the routing component of other routers, has been the traditional approach adopted by routing vendors in their products, at least until recently. Our observation that humans could manually configure forwarding tables does suggest, however, that there may be other ways for control plane functionality to determine the contents of the data plane forwarding tables. This figure shows an alternate approach in which a physically separates from the routers. That means remote controller computes and distributes the forwarding tables to be used by each router, as we can see here in this figure. Note that the data plane components of the previous figure and this figure are identical. In this figure, however, control plane routing functionality is separated from the physical router. The routing device performs forwarding only, while the remote controller computes and distributes forwarding tables. The remote controller might be implemented in a remote data center with high reliability and redundancy, and might be managed by the ISP or internet service provider or some third party. How might the routers and the remote controller communicate? Obviously, by exchanging messages containing forwarding tables and other pieces of routing information. So the control plane approach shown in this figure is at the heart of software-defined networking, or in short, SDN, where the network is software-defined because the controller that computes forwarding tables and interacts with routers is implemented in software. Increasingly, these software implementations are also open. That means, similar to Linux operating system code, the code is publicly available, allowing ISPs or internet service providers to innovate and propose changes to the software that controls network layer functionality. Okay, now let's see routers a little bit. So at the beginning of the session, we have said that a router connects one network to another network, determines the best route to the destination before forwarding traffic to the next router along the path, responsible for routing traffic between networks. But what's a router by itself, and what's exactly inside a router? Router is a specialized computer and requires the same components to operate as computers, including central processing unit or CPU, operating system or OS. For example, a desktop computer might use the Windows operating system, but a Cisco router uses the Cisco International Operating System or iOS. Another component is the memory and storage, which actually includes the RAM, ROM, NVRAM, flash, hard drive, and the other components of memory and storage. Routers have specialized ports and network interface cards to interconnect devices to other networks, because in networking, these devices should be connected to other network components. So in a nutshell, a router is a special purpose dedicated computer that attaches to two or more links or networks with two key functions. The first one, as you can remember from the session, forwarding datagram from incoming to outgoing link, and the second one is run routing algorithms or routing protocols. Router is responsible for forwarding packets from network to network, from the source to the destination. Multiple networks on a router require multiple interfaces that each belong to a different IP network. These interfaces are used to connect local area networks, in which Ethernet networks that contain PCs, printers, and servers, or wide area networks, which are used to connect networks over large geographical areas, such as to an ISP or internet service provider. When a packet arrives on a router's interface, the router might be the destination, or it may have to send it to another router to reach its final destination. When a router receives a packet from one of its incoming links, it makes a routing decision and then forwards the packet to one of its outgoing links based on the routing table information. A routing table maintains the best routes to various network destinations. routing tables are built according to the routing algorithm that the routers in the network use. For example, if the router with routing shown on the table receives a packet destined for network 2, here in this table, it will forward the packet to its attached serial line number 2, because serial line number 2 is actually the outgoing link for network 2.